Hi, everyone. Hi. Hello. Hi. Right. So thank you, everyone, for being here. And thank you for React Amsterdam and Picnic to hosting me. That's such a big audience. There's lots of you guys. Today, I'm going to talk about mocking. And mainly I want to just go through with you guys to show you how actually mocking works for one of the most common libraries that we're using every day. But before I start, I want to introduce myself. I'm Mattia. I'm a software engineer at DAZN. DAZN is like Netflix. It's like Netflix, but we are streaming. Can you hear me? It seems, yeah, right. But instead of streaming like TV series and movies, we're doing sports. We got just like a new office in Amsterdam. We opened like, I guess, a couple of months ago. Probably someone has been already bored by our recruitment team. Probably, I don't know yet. Right, you can find me on GitHub and Twitter on those accounts. Right, the agenda today. Before I start, can I ask you how many of you knows about JEST? Great, that's really nice. So today I'm going to talk about JEST, or at least I'm going to use JEST as a comparison so we can try to see how JEST works. We try to rebuild it so we can see how it works behind the scene. So the agenda, we're going through we're going to look at JEST.FNO first, we're going to see the SPYON, and then we're going to see the JEST mock. Right, have you ever experienced that feeling while you were coding? I did, but then a certain time, something happened, and I started regretting, what I did. So it's a tough, profession what we're doing. But anyway, so just because of this, one of the reasons, I decided to go deeper and see how JEST works, just to to avoid that kind of feeling. So shall we go into? And so let's see. I guess the few of you will see what I'm gonna type in. So I'm gonna zoom in as much as I can. I'm really sorry for the guys there. I was in the back and I couldn't see anything, so I'll try to do my best. Right, so what I did, I just created like a simple game. Can you see? Yeah? Sorry guys, if you want to move forward, probably it's going to be easier. I cannot move forward the TV. Anyway, so that's the game. That game is just like a function, as you can see, that accepts two objects, two params. We're going to have the player 1 and the player 2. I'm going to let them play a couple of times, and then we're going to declare the winner. The key part of this implementation is this play get winner. This one is like an external module that just sits outside this function. And so let's have a look how it is. And this one is, yeah, so this implementation, again, it gets the two player that we passed in game. And then the first thing I'm doing, I'm just like randomly creating a sign, like a number to the winning number. And then based on that number, if it's greater or smaller than 1/3, I'm gonna assign the game to the first player or the player 2. Right, so what I'm gonna do from now on, I'm gonna have two different test files. One, I'm gonna have the JEST implementation, and aside, we're gonna try to do what JEST does, but custom build. So let's create like a file, we can call it, game.test.js. On this one, we're gonna have our own implementation. So just because it's a custom one, I'm gonna use the assert library. So we're gonna require assert. Then I do need a game because it's something that is what we want to test it. I'm gonna do lots of typos, just to let you know, guys. Game. And then we need the game, that's the external dependency that we wanna, in the end, mock. Very quiet. And we're gonna have play. Right, so as a first thing that we'll do, I will just like generate the winner so we can test, we can assert if the winner is what we're looking for. So what we can have like const winner, who's gonna get the game, and we're gonna pass in the two players. So the player 1 and the player 2, because we've seen, actually, let me have a side. Too crowded, is it? Let's leave as is. And then we can assert strict equal that the winner is the player 1. So it's just like an assertion, where as a first thing, I'm just invoking the game function, I'm passing in the two player, and I'm expecting that the winner is gonna be the player 1. So I'm gonna open just a side, yeah, another terminal. Oops, I've got like a script just to have like in watch mode, so we can follow what we're doing it. And we've been lucky enough to succeed. Now it's passing it, but let's try to refresh it again and again and again and again, and it fails. Wow. Usually it takes less shot, but this time it took longer. I was start panicking. Anyway, so this is what happened. If I'm refreshing again, it passes, and then it fades. So it's a random behave. The reason why it's a random behave, it's just because we're using the math random. So that one is a random generating like a number, and then based on the generated one, it's gonna fail or succeed. I've done on purpose because like, I don't know if you do use tests on your pipeline or whatever, you wanna have consistency and reliability on your test. You don't wanna have like a random failure, like Selenium does most of the time. Anyway. I hate it. Right, so what should we do here? We wanna make sure that our test is always gonna succeed. We don't wanna have this random behave. So what I will do as a first thing, because we all use JavaScript and it's really flexible as a language, we can just override the implementation. So what we know that the play.getWinner is the module property that we are using to declare the winner. So we can just override it, just assuming it there's gonna have two players. And in this case, every time that I'm calling it play.getWinner, we wanna always get back the first player. And if I haven't done any mistake, now it always passes. And you can trust me, I can try refresh many times, it always passes now. Right, so we did something, so we achieved what we wanted. So we overridden the original implementation, and now we are consistent with the result. But there is one problem, because at this stage, if let's say I'm changing, so here is where I'm consuming the external module, and the game function is where I'm using it. So now I'm not using play get winner original implementation, I'm using the custom one, the one that just done it. But what's going to happen now? Let's say I want to break the application. I want to remove the second param, the second argument. If I'm checking it here, I'm refreshing it, it's always passing it. So it's always succeeding it. The reason why this thing happened is because this kind of overriding this implementation doesn't give us flexibility enough to catch this kind of errors, right? So what can we do about it? We can call JEST, because JEST is really clever to do that. So, and now I'm going to create another file. It's called game. I hope that you can see down there. It's just the name of the file. Is the JEST testing file. So in here, again, we do need the game. That's a game. And then we need the external module, so the play. Jest requires like an if block. So let's say should let the first player win. Right. So in here we can do the same stuff. So we can declare the winner. And we go again, we're gonna call the game and we're gonna pass the player 1 and the player 2. Right. Let me do one thing first. Let me revert back to the original one. Right. So then we can expect, as we done on the custom testing library, we can expect that the winner is going to be, in this case, the player 1. And if we check it, I hope that you can see there are 2 different running, let's say, tools. One is declared with not framework, and one is declared with Jest. So I've done it so you can see both files running together. So the first one, it points to the game.test.js. The second one, it points to the game.jest. So the Jest one uses Jest, the other one is the custom one. So both are passing it. Let's try to refresh a couple of times. Well, that one has been faster. So we are failing because we haven't implemented yet the Jest. So to override the implementation, what we can do the same as before. We can call the external module play get winner, but this time, instead of just overriding it, we can use the JEST.FN, and in here we can do the same as done before. So why I done it, I just like overridden the get winner implementation. Instead of using the original one, we are using whatever Jest does with the custom implementation, right? And now if we check in here, we got a consistent like successful behave. So it's always like passing. But if let's say we're changing to the second player, now should always fail, and it does fail. Right. But we started using Jest because we had one problem with the other implementation. The problem that we had was like, if we do change game here, so if we're, oops. So if we remove the second param, both of the testing that we did they are both passing. And so this is not what we wanted. So let's see. Something happened. Why 1 or 2? Let me shut it 1 second. Ah, right. I've never seen so big characters on my laptop. For some reason, the second one doesn't. Okay, right. So we're back on track. So let's go back to the Jest file. Okay, so now what we want to do, we want to make sure that Jest is going to catch in case we're going to break the implementation, because for now it didn't. So what we can do, we can have like a new assertion. So we can expect that the player.getWinner, so the mocked one, is going to have been called with, we can say the player 1 and the player 2. And now, sorry guys. I'm still expecting to let the player 2 win. So that's why we had that issue. So now I've reverted that back. So now both are passing. And if I'm breaking the implementation again, so if now I want to catch that error, and so I just zoom out a little bit. Actually, let me, yes. So Jest is clever enough to catch the broken implementation. And what it says, you're expecting to pass the second param, that's player 2, instead is undefined. So it's clever enough, JEST, to understand, even if we're mocking the implementation, it still keep track of what the implementation does when it's being consumed. So we can go even deeper on JEST. Sorry if I'm keep jumping it, I'm just trying to have one page at a time to have it big. So we can go even deeper because like the to have been called with has the env. I don't know if you've used it. So you can actually specify if you're calling that implementation more than once, you can actually specify the specific time that you're calling that implementation and check the arguments. So in our case, we know that we're calling twice, so we can test that the first time we call that with those two arguments, and we can also test the second time that we call with the same one, and we can check it, and of course it breaks because we need to restore the game implementation. So here we do know that we want the player 2, and now the test, it passes. We can also do one more step with JEST, because JEST, it gives us the times functionality that basically checks how many times we call the implementation binded inside the game, and everything passes, everything is fine. So just to recap what we did, we declared a winner. We passed 2 arguments, and we assert that the winner is going to be the player 1. We got consistent behave because we're using JEST.FN, and we are overriding the implementation every time returning the first player. But JEST goes even deeper because we achieve the same with the object literal that we've seen earlier. But JEST is also keeping track of the every time that we are calling the implementation, and so it gives us all of these new functionality to have been called with, to have been env called with, and call times. So, question to all of you guys: is it magic? Tricky question. Right. So is one of my favorite guys. So shall we try to reinvent JEST? So shall we try to see how JEST works? Right. Okay. I'm zooming out a little bit. So when I'm start looking for this thing, the first thing that I did, I wanted to know what the JEST.FN does, because in order to reproduce that behave, we want to know what JEST.FN does, because it's actually like a method. It's like a function who returns something. So the first thing that I did, I just console log the play.getWinner. And if we look at, I hope that you guys can see it. No, you can't. So the JEST.FN has overridden the player get winner, and instead of giving back the normal implementation, it assigns lots of new properties. You can see listed there. And the one I want to look at is this mock property. So let's go back in our code and let's console log the mock object. If we console log that, if we console log it, we can see that mock itself has other properties in it. And one of them that I want to look at is this one called calls. So if I'm console logging calls again, we got this thing. So what we got is just an array with inside the array, we got added to nested array. So by looking at this, I'm start understanding a little bit more what this to have been called does. Let me zoom out a little bit so you can actually see them. So if you look at the to have been called times 2 is nothing more than the array dot length, because we do know that we got two objects, the first array and we got the second array. And the same for the to have been called with, especially with the nth called with, if you specify the index of the array, let's say you want to get the first element inside the array, and so you can test it, you can check it and assert that the params passed in are exactly those ones. And so you can test again that the second index so 0, 1, but JEST is clever enough to swap them, is going to check that the arguments is going to be player 1 and player 2. So now that we discovered this, it starts making more sense, no? It's like start, you know, being more human than magic. So we can actually swap these 4 assertions with just one of them, because we know that we can expect that the play.getWinner.mock.calls, it has to be equal to an array who has a player 1, who has, who has a player 2, and my mouse is gone. What happened? I don't get the focus on my terminal. I don't know what happened. Sorry, I'm just shutting down. No. Okay. Never do live coding, guys. It's just a suggestion. Anything could happen. So let's start again. So we were in JEST came. Right, and aside we are going to start again the testing. Right, okay, so let's go back here. So what I was saying is, what we can do, we can replace these 4 lines of anticipation with just one of them, because we know that in this case, the mock calls has inside those 2 properties. One is the array with the first call, and the second one is the second call. So I'm gonna go here and gonna replace them, and the test is still passing, and I can prove that that works, because if I'm removing the second block, let me go here. We can see that is missing the second one. And the same if I'm changing just one of the element in here, is gonna do the same. So you see, I just removed the 1, it's gonna check what you're expecting is not what you're receiving. So great. Now we know something more of this. So let's try, shall we try to do the same things that JEST does, but in the custom one? So what do we know? Can I keep those aside? Is too big? It's fine. So what we know that JEST in here, it wraps the implementation in a JEST.FN function. So instead of being JEST, we're going to just call FN. This FN is going to wrap this implementation. So it's the same as this. And then it's going to do something. So let's start creating this FN function, right? So JEST, I'm assuming that does something similar. So we have declared the FN function, who accepts like an implementation. And inside implementation, we need a callback. So what we're doing it, we're just instantiating it with the, let's say, mock function. And then from now on, we know that we're going to pass as many arguments as we wanted, because in this case, we know that we're passing 2 of them, but we are abstracting the FN function. So we want to accept as many as we wanted. So that's why we use the spread operator. And then we want to just return the implementation, passing it all the arguments. And last bit, we need to return the callback. Right, so shall we see if it works? And it doesn't. Wait 1 second. It's still the JEST one. Yep, here we want to revert it back to the original one. So now everything passes. So we're back on track. And just to prove if I can break it, let's say that our fn function, the implementation, we want to return the second player instead of the first one. So just to make sure that the function works. And if we do that, it fades. You see at the top, the not framework one at the top, it expects to be the player 2. Instead, we declare the player 1. So let's make it pass. And everything passes again. So let's review what we did. What we did, we just create like this function fn to abstract the implementation that we want to pass in. So what we're doing it, we instantiate the function with an implementation. That in our case was like the p1, p2, and return p1. But then we're going to store inside, and we're going to assign as a callback mock fn as many arguments as we wanted. And when we're going to trigger it, we're going to pass the arguments. Oops. We're going to pass the arguments to the implementation. But it's not enough, because like what we achieved with JEST was like one step further, because with JEST, we should be able to do the strict, deep equal. We want to know that the, where is it? Play.getWinner.mock.calls. Do you remember? I'm trying to follow the same structure as JEST, as to be equal to an array who has the player 1, the player 2, and the second call. So this is exactly as the JEST, just as a comparison. So this one is JEST1. We checked, we saw that the getWinner mock.calls has all the codes in it, and we tried to achieve the same result, but with our custom implementation. So now we need to implement this. So we need to find a way to store every single calls that we're doing it inside this object. So what we can do first, we can just create that object. It's going to be mock, and we're going to assign to that object a calls property that we can instantiate as an empty array. By having that, what we can have, every time that we are calling the implementation, we can just keep track of it by pushing every argument inside this mock calls. So, and if I haven't done anything wrong, it passes. So now we achieve the same JEST.FN implementation with this function that we've seen earlier. Then, as a second step to keep track of the calls, we added the mock function, so the mock property, and inside we got this calls object, who's instantiating as like an empty array. And the second thing is, every time that we are calling the implementation, we want to keep track of every argument. So by doing push, we are keeping tracking inside the array. If it's not enough, now we go SPYON. Right, so I'm going to switch back to JEST, and I'll close this. At this stage, if I'm trying to console log the play.getWinner, and I'm looking at what our look like, it's still the mocked implementation. But it's a good practice to like revert it back as soon as you finish to test your dependency. It's a good practice to revert it back to this original behave, because you don't want to have the mocked one all over the place. So what we can do, we can just like save somewhere the original implementation, original FN. And then in here, we can just pass the original implementation. That's going to be the getWinner. And then right at the end, we can just revert it back with the original implementation. And if we check it now, let me just remove this console log here. It's no longer needed. Right. And if we look at this now, we got the function reverted back. So it's no longer the JEST.FN one, but it's going to be the original implementation. Jest is a lot more clever than this because Jest has like a tool built in that SPYON. So the SPYON implementation, so we can replace these saving and restoring implementation and using the Jest one. Jest has something called SPYON. It's like, again, it's a function who accepts like an object that's going to be our module, play in this case, and accepts like a property that for us is getWinner. So JEST.FN, we're using, instead of FN, the one we used before, we're using the SPYON implementation. And the SPYON, as the documentation teaches, requires like an object, there's going to be the module itself, and then the property that we want to mock. And then once we do this, we can actually pass in a custom implementation, because our end goal is like having a custom implementation for play getWinner. So to do that, JEST.FN has something called mock implementation, right? And by having this, it gives us one more property, that is mock restore. So if I haven't done any typos, yes. So we achieved the same result as before that we done with FN, but now we got one layer on top, that is the SPYON. And so the SPYON gives us mainly two functionality. The first one is still gives us the opportunity to have like a custom implementation. So in this case, we're always going to return the first player. And second, it gives us the opportunity to restore it back without doing any weird stuff like I did it before. So we can just restore it back. And just to double check it, if we move this before restoring it, we should still have the mocked version of Jest, and we do have it. Right. So shall we try to have the same implementation? Not together? Yes. Okay, so test. I'm going to keep it aside so we can compare them. So, right. So your right side is test, so our custom one, and on your left side is Jest. So what we did here, we just create like this object within SPYON, and then by doing this, we mocked implementation. So in our own implementation, what we're expecting to have something that we can call SPYON, and in here, SPYON. And in here, we know that we need to pass like an object. There's going to be play, the module itself, and then we want to pass in the the property of that module. It's going to be getWinner. Once we do this, we can just replace this FN, and as Jest teaches us, we can use the mock implementation. And right at the bottom, we got the play.getWinner.mockRestore. So this is what we want to achieve, correct? So I hope that you can see that basically the same. So we got the JEST.SPYON object and the property. We got wherever we need to build it yet. We got the SPYON with an object and the property, and then we can have the custom implementation, and at the end we can restore it. So I'm going to close this. So how can we do this? We need another function that we can call SPYON. Let me give for space. So what we already know that this function needs to accept two arguments. The first one is the main object, and the second one is the property that we want to mock inside the object. So within this function needs a T. What we need first, we need somehow to store the original value, right? So we can do the same as we've done before, original function. There's going to be, in this case, because it's like abstraction, is not a specific one, but it's going to be wherever object we're going to pass in, property. So in this case, the will be play.getWinner implementation is going to be assigned to this const. So original function from now on will save inside the closure of this function the original implementation. As soon as we got this, as a second step, we wanna override the implementation because it's our end goal. So what we can do object property is gonna be the function. So the one these, if you read instead of object and property, if you placed play get winner equal FN is the same that we did before. We just done one step further, that is like saving the original value. So in this case, we're instantiating the get winner with an empty FN function, but the FN function is expecting to have an implementation. So we need to pass like a default value as an empty object, otherwise we'll break. And the last step is revert it back. To revert it back, we want to have like a property called mock restore, that when we're going to call it, we actually want to revert it back. So we want that the object property is going to be the original value. Yes, thank you so much. Any other typos? No. Right. We missed the last, there is another one. You have to test for executive, right? Yes, yes. But I prefer not doing this, you know. I don't like the red stuff. I will do like the girl that I showed you earlier, that being said. Anyway, so what we achieved now, if we look here, we achieved, so we create the SPYON function, we accept two properties, and we got this mock restore property. We are missing the mock implementation. So let's add this mock implementation. In this case, the mock implementation has to be inside the function itself. So in here, we know that we want to, the mock FN is still the main object, the main callback. In here, we need the mock implementation, that is like a property, that when it's called, accept like a new implementation, because we're going to call it a second time. And then once we trigger, we want implementation being, we want the new implementation be assigned to the implementation. I want to spend 2 minutes to explain you this mock implementation. So starting from the SPYON, and the SPYON, we saved the original implementation, and the reason why we saved it is just because we want to revert it back. So original value stores the original implementation, and the mock restore allow us to revert it back. The step in between is just like overriding the player get winner implementation with all of these functions here. So we're going to just assign that function to the implementation, right? So after this step, object.prop is going to be wherever we're passing inside here. That's why the mock implementation needs to sit in here, because the prop from now on is going to have this scope. And the mock implementation, just because like once we override the implementation with the FN, we are not passing any implementation. So at this stage, we're going to have like an empty object. That's why declaring the mock implementation, we can revert it back. So what we did, SPYON, we declare the function, object and property, we save the value, we instantiate with an empty function, and then we got the mock restore to restore it back. The implementation, we need to pass like a default empty object, and the last thing that we did the mock implementation. We haven't tested if it works, and it does work. Oops, I closed the wrong one. Yes. Right, so last step is just mock. So what we achieved until now, I keep closing the wrong one. Yes. Let's open JEST again. So what we achieved until now is called monkey patchy, because that means it's like we're still mocking an implementation, but by importing the real module. So we got the real module that is up here, play. And then once we got that module in, we're going to just override the implementation. If we do the custom one, or if you use the jest one, it's still the same. So if you want to go one step forward, we can actually replace the entire module. So once we do this, instead of calling wherever is on play file, we're going to actually call a new module, an entirely new one. And jest gives us the mock property that actually you need to point to where the module is. So in this case, we know that is on that path. And then once you got this, you can return wherever property you wanted. So we know that getWinner is the property that we want to override. So we're going to override this one with the JEST.FN. And again, this one is the same as we saw earlier. So jest mock, it entirely replaced the module. So instead of calling play, it actually calls wherever I'm declaring in here. So play won't be importing this module. And now, if we don't need anymore to spy on, we don't need to mock implementation, and instead of doing mock restore, it's going to be mock reset. And if I haven't done any typos, yeah, it works. And as you can see from this console log, we still got the mocked. This one is the mocked version. And you can see because we're console logging it. And if I'm doing, it works in a different way, so it's not important. So just, sorry, closed it. Right. Never use Vim, guys. No, I'm joking, it's really cool. Right, sometimes. Okay, so let's do this final step. So we wanna have something in our custom implementation that's gonna, instead of getting the original module, is gonna get a new one, wherever we wanna pass in. So let's go the test in here. Right, so as a first step, as always, I do like console log. So while I'm console logging the required, because I'm using common.js, and I'm console logging the required.cache. And if we look at this, there are lots of like stuff, but they're like recursive, because what this thing console logged is like every module that's been imported in that specific file. So they're all declared here, and they all follow the same structure. So every module needs needs an ID, and the ID is just the path where the module is stored. We got the export, the actually properties they go in. You got the file name, again, the path of the module. And last, we got the loaded as a true, otherwise it won't be loaded. So now we need to find a way to swap the original one with the custom one. 2 minutes, promise. Right, so what we can do here, first of all, we need to get the path where the module is. So I'm just going to declare a const, let's call it play path. It's going to be required.resolve. And in here, I'm going to declare the play module, right? So now I know that this play path has the URL of the play module. Then we've seen it that the required.cache has every module, so we can specify the module that we want to look at. It's going to be the play path. And now that we saw this, so now I'm just referencing at the specific module play. We know that we need an ID, and the ID needs like the path of where the module is. We need the file name, and it's going to be play path. We do need it loaded. It's going to be true. And then the most important part is the exports. And inside the exports, we can customize the properties. We know that we're looking for now a get winner, but we can have as many properties as we wanted. And the get winner itself, we want to actually use the custom one. So it's going to be P1, P2, and P1 again. So if I'm removing them, so now that we got this, right, we don't need to spy on anymore, as we done for Jest. We don't need to mock the implementation anymore. And right at the end, instead of doing mock restore, we can use the delete require cache play path. And if everything is fine, yes, it still works. So as a recap, what we did, first of all, we got the reference of the play module and we stored in the play path. And then what we actually did in the require.cache, where we got every module that we're using it, we pointed the specific module, play, and we replaced the implementation. And by doing that, we needed the ID reference, file name, and loaded. But what is important is like inside the export, we can customize the specific properties in each of them. Oops. If you want to know more, they're like the JEST.JS, I missed like a J, or Can't See Dogs has, seen this kind of topics. That's all. Thank you, guys.